Hello everyone, welcome back to another video of the Math Geek. In this video we are going to do a very cool problem from Khan Academy. As soon as I tried this problem, I absolutely loved it, and I know you will too. So without further ado, let's start achieving greatness. Alright, so they want us to find the length of the line segment CF. Pretty straightforward. But getting there is very hard. So what we want to do is we want to prove similarity for as many triangles as possible. So once I look at this, there are two that jump out for me as similar. Pause the video and see if you can identify the similar triangles. I'm assuming you've paused the videos, and I'm going to tell you the similar triangles. They are CFE and ABE. And why are they similar? I'm going to tell you why. So basically CFE and ABE actually share a right angle. I didn't write it in, but they do share a right angle. So let's write that in right now. That looks like a nice right angle. And then ABE also needs one. Also looks nice. So both of these are right angles. And then they have a shared angle, angle CEF. So we're going to also need to draw that angle in, CEF. This one is shared between both of the triangles. There, that's good. And then the other angle is also congruent, because we have two congruent angles, meaning that the third one is also going to be congruent. Okay, so now that we've established similarity, let's just write it down and get it out of the way. Okay, so let's color code this. Triangle CF CFE similar to triangle ABE. Great. Now we've established one set of triangle similarity. Let's see if we can establish another pair. Pause the video and see if you can identify the other pair of similar triangles. Well, it might be pretty obvious that it's CBF and DBE, because we can apply the exact same logic that we did for these triangles. They share a right angle. They share a right angle. Let's make the right angle for both of these. It's not a very good right angle. Actually, you know what? Let's just use our brush. Doing a square is very hard. That's our first right angle, and this is our second right angle, right? Next, they have the shared angle CBF. So they have a shared angle of CBF right there. And if those two angles are the same, the other angles are going to be the same. So these angles are congruent. Okay, so triangle CFB, CFB. Think that's the right color? Yes, it is. It's not, but we'll go with it. CFB is similar to triangle ABE. Sorry, DBE, not ABE. DBE. DBE. Sorry, it's DEB. I'm sorry. I wrote that in the wrong order. These are the corresponding angles. And that's why you color code things, so you know which the corresponding angles are. So now that we've written both of these similarities, let's see if we can do anything else. Doesn't look like there's anything else we can do because we have already established all the congruent angles, all the congruent similar triangles. What else could possibly be there to do? Turns out there is a lot. So let's just simplify things for you. We're going to call this whole thing y. We're going to call this x and this y minus x. So the line segment BE is y, BF is x, and then FE obviously has to be y minus x. So y minus x plus x is going to be y, the whole length. So we've written those, and now what I want to do is I want to compare these corresponding sides. So let's first compare the corresponding sides of this first triangle right there. So what side does CE correspond with? CE corresponds with AB. We take the first two letters. So CF, I'm not going to color code these because we already know which ones correspond with which. CF over AB is equal to second two letters, FE over second two letters is BE, FE over BE. That's equal to the first letter and the third letter, CE over AE. Now, can we substitute any values? Yes, we can. AB is going to be equal to 9. So let's select that, delete that, then put 9. And then anything else? Yes, FE is going to be equal to y minus x. Y minus x. And then BE is going to be equal to y. It's going to be equal to y. And then this we can't substitute anything. So we can already say that this is going to be useless because we can't substitute anything. Okay, next let's do the second pair of triangles. Second pair of similar triangles. CF, first two letters, CF over DE is equal to FB over EB, FB over EB is equal to CB over DB. Now let's substitute the values. DE is going to be equal to 12. FB is going to be equal to X. It's going to be equal to X. EB is going to be equal to Y. It's going to be equal to Y. And the last one, we can't substitute anything, so it is useless. We have these two statements right here, and we can see that both of these share a common denominator. Now, let's see if we can simplify this or rewrite this y minus x right here. So y minus x over y. What is this? That's equal to y over y minus x over y, right? This is 1. So it's equal to 1 minus x over y. Let's rewrite that. CF over 9 is equal to 1 minus x over y. And CF over 12 is equal to, not xy, this is supposed to be x divided by y. Sorry, x divided by y. And CF over 12 is x divided by y. What do we see here? X over y in both equations. let's substitute x over y for CF over 12, because we know they're equal. So CF over 9 is equal to 1 minus CF over 12. Wow, that's very, very interesting. Let's add CF over 12 on both sides to isolate the 1, getting CF over 12 plus CF over 9 is equal to 1. Okay, so now let's find a common denominator between these two. So 12, would that work? No, that wouldn't work. 12, 18, 27, 36. Oh, 36 might work. Yes, 36 is a multiple of both numbers. So, what do we need to multiply by 12 to get 36? We need to multiply by 3. So 3CF over 36 plus 4CF over 36 is equal to 1. And that means 7CF over 36 is equal to 1. Now if we multiply by the reciprocal of 7 over 36, we get CF is equal to 1 times 36 over 7, or CF is equal to 36 over 7. That is our answer. And we've actually proved something very, very cool here. It doesn't matter the distance between B and D, the height of, the intersection between the hypotenuses of both of these right triangles is always going to be 36 over 7. Thank you guys so much for watching this video. I hope you like it. Make sure to like and subscribe, and see you in my future videos.